In this video, I'm going to show you a few more features of this board and the software, as well as the SRIX 4K. So I'll be referring to this document, and I can't stress how important is this document. So please get a copy. I'm going to keep it on my next screen. So before I start, few people asked me, where do you get this SRIX 4K? And I bought few samples from here. Go to alibaba.com and type SRIX 4K. You get so many things in here. But the problem here is you have to buy in bulk. Say for example, this vendor is selling minimum piece for a price of $0.1. So if you ask for 1 or 2 piece, the numbers will swap. So it will be £1 or £2 each. So I will leave it to you. If you want to play with the type B type of tags or SRIX series of tags, you just have to find a good website for you. So I bought from this site. So as you can see here, I've connected the demonstration board, and I've got this software running. So what I would like to show here is, we know that, and just we are using SRIX 4K for this demonstration, and that's the only tag I have got. You have seen in all my previous videos. So wherever you are, probably you can buy any of this. We know that SRIX 4K is ISO IEC type B tags. So there is an option here, ISO IEC for type B. This is the best screen you can use to learn how this the anti-collision and selection works for a type B tags. There are so many documents in internet, and please read them. Read the document, come to the screen, play with all these options, so that you'll be good in this concept. However, if I try to use this screen, if you look into any documentation of ISO IEC 1443B, it starts with sending the REQB, the request for type B. After that, sending the attrib command, then the card gets selected. Somehow I could not get this SRIX 4K tag working with these type of commands. So if you look at the document, we are supposed to get some response here. Either the response is called A2 ATBQ, that's answer to request type B, sorry, A2QB. So I'm not very sure why this card doesn't respond to these type of commands. Look on internet, I've seen some people saying that SRIX 4K runs on a proprietary protocol, and it runs on a different maybe some kind of commands. So I'm not very sure, but let me also try with sending this as 1. So nothing works here. So probably I will start using this screen if I get hold of one more type B tags. Somehow I find very difficult to buy this type B type of tags. You can find lots of type A tags, all MIFARE tags, you can buy for much cheaper price, type B. Okay, the next thing, going back to this screen again, you can select, you can see here there are so many um, versions of SR tags. So if you select, I did try on this one, so we know that okay, this is a 4K tag. So if you try initiate, select, and UID, and let's try to read the first 12, so 16, read. So it looks like these tags are compatible. So I think, I'm not very sure the difference between the SRIX. I know that I also mentioned in my previous video, X, it's a anti-cloning feature, and this is I don't know, maybe this is without anti-cloning probably. Okay, so 4K is 4. I think one thing I came to know is the number here 512 refers to number of bits, not bytes. Okay, it's a bits, it's a 512 bit. So let's try to select the first one, this. So I'm reading this as a 512 bits memory. To initiate, yeah, I think this doesn't work. Initiate doesn't work, so it doesn't work for 513. So it looks like only these two are compatible. The first two, these two are compatible. Let's try with the two. Maybe it's two. Maybe I think this has got a different structure altogether. So let's try with the. Let's try to place it again. Try with 2K. Initiate, yeah. So initiate returns you the chip ID. Select and get UID. See here, all these SRIX series tags, they all return 64-bit UID. I found a nice document from st.com website, and I'll show you what these numbers represent. So here let's go, and as you can see here, automatically, because it is a 2K tag, the maximum address has changed to 3F. So it looks like I should be able to read. Yeah, so I can still read. Let's try to write something here. Just go. So to be careful when you write. If you just go and write a single block, you'll end up writing a whole lot. So to be careful with that. Just try to read again. Yeah, let's try to read only. Yeah, so here write. So write 41, 42, 43, and 44. Write the block and read. So we're able to write it. Okay. So I think this is something you find in the MIFARE tags as well, because my experience is more on the MIFARE tags. Say for example, in MIFARE, you got ultralight tag. We also got ultralight C, or it can be say NTAG 203. So whatever is this, for all these tags, the ultralight has got 16 pages of data. So all the higher version of these tags, the first 16 bytes are the same. So you can still treat these tags as a basic ultralight tag. I think this is called probably as a backward compatibility. Okay, so the next thing I would like to show is about, we discussed quite a bit on anti-collision. So let's just recap. Probably it's like a recap what we did. So I'm going to use, if you got only one tag, or if you are using this for the first time, if you just go and hit this button ISO IEC for anti-collision, we'll see what exactly it does. It's very interesting thing. We know, if you have seen my previous two videos, you already know what's happening here. So I'm going to clear. Okay, So if you see a UID here, that means this hitting this button has done a lot of things. It has also selected, and let us see what has done. And keep in mind, this software from st.com is the best reference for a developer to use the DLLs, because it tells you exactly what command in the DLLs are used and what the command data to be sent as well. But these things I'm not very sure. It says if you hit this button, there is some command called PO reset. It's something to do with the reset probably. I don't know why it is doing twice, and I think it's something, there's some difference here probably. um, it is something to probably RF, I suppose. Yeah, RFPO, or probably it's trying to, it's, yeah, I think, yeah, I got it probably. Now what this could be is it's going to turn off the RF signal. So when you turn off the RF signal, all these tags, they go into, the unpowered state. I think this is, and after that probably 00 means, to uh, bring the RF on. So this is something, rather than me lifting the tag and bring it back. Okay, probably that's what it does. Let's try again. Clear. Okay, so whatever it is, okay, it's good to know that these things can be done through the software. Okay, so the first command it does is it resets to inventory. This command, if you see the documentation, I'm just going to open the documentation on my other window. If you go to the section 9.6, there is a clear explanation about what the reset to inventory command does. So it says all the selected tags in the RF field will be forced to go into the inventory state. Okay, so probably this is a very safe command. Just after that, we have tried this thing. So first thing is initiate. So when initiate, that all the commands, this will make all the command to generate a new chip ID, and after that the pcall 16. So just make a note of that. So here it is 7F. So 7F in binary will be 1 1 1. This is 0 here, okay, and 1 1 1 1. So we know that this is the chip, or the chip, I think chip slot number. So please read the documentation. This is very easy to understand that. See, the last 4 bit is what is used by the pcall. So it is F. So this card will reply only when the slot number is 15. So what this loop does is, it will first look for, the pcall 16 is also same as slot marker 0. Or it's asking, okay, oh, is there any tag with the slot 0? Nope. So this command slot marker 1 is checking for any tags with the slot number 1, and we know that this chip's slot number is 15. So this is like asking, oh, is there any card with slot number 1? It says no. Is there any card with slot number 2? The answer is no. So likewise, it keep asking, the number goes from 1 to 15, and look at here. So is there any chip with slot number 15? Yeah, the reply is yes, there is one, and that has returned the chip ID is 7F, and after that chip is selected, and I don't know why there are two select command here. Let me check any difference. Not very sure. And also the get UID. So let's try this again. So I'm going to again initiate, or sorry, try this again. Click here. So this time you got a 6D. So here the slot number will be the D is for, I think is 8 12 0 1, and it's the 13. So let's go and see whether is anything happen with chip with the slot 13. Yeah, as you can see here, the slot 13 got a reply and got selected. If you notice something, this loop did not stop after slot 13. It's checking for, is there anything with slot 14? No. Is there anything with slot 15? No. Then it just selects another one. Let us try to keep 2 tags and see what happens. I'm going to try again. So I have 2 tags here. Clear. Okay, so looks like nothing has been. Let's go through that and see. Sorry, let's go through that. Okay, we know reset inventory, initiate. There's something wrong here. It could be a collision. Checking for the slot 0, no reply. Slot 1, no reply. So like that, we get for slot 4 there is a reply. So there is one tag with slot 4, and it's also got selected. And the slot 5, looking for slot 5, so nothing happened there. And eventually in slot 12 there is a reply, and a select command was sent to slot 12 with this the chip ID. And keep in mind, so we just saw the first card was selected, okay, and this second select command will deselect the first card. So after that it continued for 13, 14, no reply, 15, and eventually now we know that the last card that is selected is the one with the 4C, sorry, the 6C. Probably if I go and say see what happens. Yeah, so this ID probably it didn't fill anything here, but so that is how the anti-collision works when you got multiple tags. So if you go to st.com, you can download this document. So this document says that every card from ST manufactured by ST has got a 64-bit unique ID, and there is some easy explanation about how to decode those 16 bits. So as you can see here, the 64 bit has got the tag category in the first 8 bits, followed by the manufacturer code, followed by the product code, and followed by this unique serial number. And this unique serial number is 42 bits. You got massive. It's I don't think this will repeat. So I'd like to show now what I have done in my VB.NET program. And this program, I spoke about this in a couple of 1 or 2 videos in my previous videos. So I'm going to show you how to decode those 64-bit number. So I'm going to try with just one tag, because this program doesn't work with more than one tag. So this is a program, it just shows whatever is in the document. There's nothing more than what's in the document. So if I click on a go, so basically I'm reading the entire tag. If you see here, the commands are the same, read and write. Okay, to write a program like this, you have to follow my previous videos, and as well as the document about using the DLL from st.com. So I've just made a small change to this program. If you remember this program from my earlier videos, the byte ordering I have changed here. Before it was B0, I just want to make this screen look like what's in the what'shistory.com document says. Now every block is a 32-bit. With this is the first is the most significant bit. So everything here works with the same byte order. If you go to the system tab here, I'll tell you something I did. This card literally is no good for me because I did something. I was playing with this, and something went wrong. You should never see the chip ID as 0. Don't try to set chip ID as 0. You can't. It's not a good value to have. Okay, if I type get UID, see this is the value that's returned. There is a small bug here. I think this is again reverse order. Okay, and when you decode this, value, the D0 means it is a, again, whatever you see here, it's well explained in the document I showed you. D0 means it's a IS41443B type of tag. The manufacturer code 02 is ST microelectronics. So because I worked in a lot with the MIFI tags, if for NXP it is 04. I think that's why most of the 7-byte UID in MIFI tag starts with 04. And this is the IC code. There's something wrong here. This is not supposed to be SR176. There could be a bug in my program. Let me fix that and show the screen again. Okay, sorry guys, that's fixed now. So this is the 64-bit unique identifier. So every tag is unique. So the D0 means it's a of type B tags. 02 is the manufacturer code, and 03 here, this is not something straightforward. This is some bit, few bits out of this lot, and this is the serial number. Okay, so there's something now I would like to mention here. See, the documentation says this is the SRIX 4K document. So if you go to the page where it speaks about a fixed chip ID, in section 4.4.2, so there is a mention about how to give a fixed value for this chip ID. So I tried to now give a value, but I couldn't. But I ended up writing 00. And now what's happening is, whenever you try to change the values of this the last block, the system block, you have to reset the tag. I know this is this tag is I'm going to literally destroy this thing. I'm not going to keep this anymore. What I'm going to show next is, so assume that we have used this card in our software. We have done a project. How do we protect? See, I can have a separate video on how to protect it, but just to make it simple, we know that in case of SRX 4K, the thing I like most is the OTP are resettable. So just want to briefly mention, I've done this in my previous videos. Just a quick one, in order to make this, if you want to reset back to 00, what we end up doing is, one of the counter in block 6 here, documented says the 11 bits are for the reload counter. I'm going to make it as 4, and I'm also showing what is the likely the new values of this block here. So make it I'm going to write it. So I've changed this counter. Keep in mind, these counters, they can only decrement, they can only reduce them, you can't increase it. If you go to OTP now, I can say clear and write. So look at that, I've just cleared all the OTP bits. This is just a shortcut to clear all these checkboxes, right? Okay. Now if I want to write, assume that I got some OTP here, probably I've written the something, the name of a customer, or for, so I'm going to write this as well. I'm going to make this counter as a 0. You can never reduce this any further. So this is, by setting a value to 0, we are making this OTP as completely write protected, and this is irreversible. You just cannot get back. Can't make it more than 0 again. Let us do that. I know that I'm going to waste my 3-pound tag now, but it's alright. Okay, so return 0, and let's try to, I'm going to place this tag again, and look at my OTP, it's 0. Now if we change, assume I want to try to remove some of these ticks and add some new ones. I can add, so you can't write anything here. So because it's a write failed, so we know that you can't change the OTP. Just a minute, I should be able to at least read it. Okay, sorry, try something. Sorry, let's go and clear these logs and see what's happening here. Yeah, write is okay. Maybe that was a glitch in the software. Yeah, it is able to write, but remember, you cannot remove this existing tags. Just go and clear. So this is the value I want to write. I've tried to remove some of the ticks here. Right. Now you got back. When I read, you got back the old ticks, but only the new ticks are saved. So now this tag now is basically to put in other way. Now this is the auto recycle is permanently disabled by setting this counter value to 0. Likewise, you can also use this counter. Assume that if I make this or use this card for an event card. So I'm going to assume that I want this card to be used for 15 days. Okay, so I'm going to set, so in my program I can use this counter, so to make a tick on when the event has been attended. So I can keep on reducing this to 15, 14 until it reaches 0. And now you cannot increase this thing. If you try to increase, this is you can't write it. This is my validation, but if you see the documentation about this, it says you cannot increase it. So this is, I put a validation before you write. Okay, so anything else we got here? You got one more counter here, so you can use this counter. See, there are two counters. Okay, so I can also, you can assume that I want this to be 100. For example, this could be a club pass, say 100 entries or 100 days. So I can set this 100 days, and every time the card is used, I can keep on reducing this, and when this reaches 0, I can probably say that this card is no more valid.